Hi, welcome back. In this demo, we're going to look at actually connecting to the database and using it to run some tests to make sure that we're doing things correctly with our catalog. So the first thing we need to do in Xcode when we're running with SQLite is that we need to import the framework, or actually it's a dynamic library, and we need to link it up to our application. So the way we do that is we click the plus button here in the build phases under Link Binary with Libraries. We click the plus button, and I've already done this, but I'm going to show you how it's done. And we scroll down to libsqlite 3.0. Now, let me find this. There's a lot of libraries. Okay, if we look, we'll see that there are two actually libsqlite. Don't use 3.dylib. Use 3.0.dylib. This is very important. So then, once you have selected that library, the correct library, we need to go ahead and add it. I've already done this, so I'm going to click Cancel. And we can see that it shows up here in our frameworks, and it will also show in the frameworks folder if it's properly linked. It is, actually it doesn't show up in the frameworks folder. It shows up here in the build phases. The second step is wherever we're going to be using SQLite, which in this application is only in our parts model, we need to import the SQLite3.h file. Now this will give us access to the C API that is embedded in iOS for SQLite 3. Alright, so now that we have that, we can write some functionality. We're going to have on our parts model some catalog functions and some inventory functions. And we're only in this demo going to look at the catalog functions. We'll look at the inventory functions a little bit later. Now, the first two functions are a pair. We'll have open database and closed database. And this is very important. Before we do operations on our database, we need to open it. And then after we perform operations with our database, we'll need to close it. So those two run in sort of a pair. And we'll do that from our main view controller. The next function we have, or the next method, is add to catalog with name, description, and reorder. Then we'll get we have a select query, basically, that is wrapped up called all parts that returns an NS dictionary where the keys are the part numbers and the values are an array containing the name, description, and reorder quantity. Finally, we have two delete functions. The first is sort of a utility function, if you will, or a utility method. Delete all parts from catalog. While we're testing, we want the ability to get our catalog all the way back to a pristine state. Now, this isn't going to reset our IDs, but it will delete and remove all the parts from the parts catalog, and this is exactly what we want. And then we're going to have delete catalog part number, and we'll pass in the part number and delete only that part number. So before I look at these methods, we have a test that we're going to run, and that is in main view controller. And we can see right here in view did load, we're running our tests. So from before we have the test, and we can really just comment this one out. Test is going to be removed from the parts catalog, or from the parts model anyway. So we'll just comment that out for now. We can see that we run our test by first opening the database, and then we're going to add two parts. We're going to add part number PN001 with name first part, description first part added, and a reorder quantity of 15. And then we're going to add PN002 with second part added, and a reorder quantity of 20. The next thing we do is just we're going to run all parts, that select query in a database, and report that out. So we're going to log that dictionary out, and then we're going to delete part number 001. And then we're going to, again, log out all parts. And then we're going to delete all the parts from the catalog, which will just be part number 002. And then we're going to, again, run all parts and log that out to make sure that there's nothing in the database in the catalog table. And then finally, we'll close the database. So these are our tests. Now let's look into parts model, the implementation, and see how these are implemented. One of the things about SQLite 3 is that you must remember that this is a C API. it is great and a very good thing to be able to specify our strings as NS strings, our queries, and then pass them in. But remember, we have to convert these into UTF-8 strings. The first thing we're going to do, here's the open database and closed database, and they're very simple. We need a handle to a database file. We have a property on this class, parts model, called self dot, I believe it's parts catalog, and let's look at that, or parts database, and this is our database handle. We can see that it is non-atomic and assign. It is a pointer, but it's not an object type, so we make it assign, and it's of type SQLite 3. So this is our parts database, so that we can call that self.SQLite 3 inside our parts model. Makes it a little bit more simple. So now we have a database file, which is the path to the database file given parts.sql as a UTF string. So here's the first instance of having to use a UTF string to get this. Then we set up a connection, and then we attempt to open it using the SQLite_open function, and we pass it that database file and a pointer to, or the address of, that connection, and we make sure that we get back SQLite OK. And if we don't, we just log out cannot open database and return. Otherwise, we set our parts database pointer to that connection, and that's simple. That's all we have to do to open the database. Closed database is even more simple. We call SQLite_close with that parts database pointer, and then we set the parts database to nil. We don't want that pointer sitting out there pointing to something in the heap. Okay, now let's look at add to catalog. This is an SQL insert query, and I'm passing in 4 parameters: the number, the name, the description, and the reorder quantity. So the first thing I do is I set up a query, and this is an NS string. And I'm setting it up as string with format, and it's going to be insert into catalog, and then the fields, part number, name, description, reorder, and then the values. And notice that I have to escape the double quote character here because I'm in a double quoted NS string. So I escape that and pass it in our parameters: part number, part name, part description, and the reorder quantity. And then I have a commented out NS log here. This can be useful for troubleshooting. I'm just logging out that SQL statement. The next thing I have to do, and this is a pattern that you will see over and over and over with SQLite 3, is that I need to prepare the statement. So the first thing I do is I make a thing of type SQLite3_statement, STMT, and this is a pointer. And then I make an integer, and this is usually called result. And I call the SQLite 3 function SQLite3_prepare_v2, version 2. I call it with the database pointer a char star, a constant char star that is my SQL evaluated as a UTF string. The next argument is the maximum number of characters, bytes, in the SQL statement. If this is not negative, it uses this number to truncate your SQL statement. If it is negative, and it is in almost all cases, it just says take the entire string. So we use -1. I tend to use -1. It's just very simple that way. The address of my SQLite 3 statement, and then a null. This argument refers to the number of extra bytes, or actually the rest of the query that's passed in, if this argument is not negative. So if this is -1, we can use null here. However, if you do some sort of weird counting into this statement and count a number of bytes, and then you want to execute some last part of the statement later, or if you have multiple statements, then you need to supply an actual number here, a non-negative integer, and then this will be a pointer to the remainder of the statement. We check to see if that result is okay. And if it is, we run SQLite 3 step on the prepared statement. So here we have an address to insert this uses this call by reference type to actually put the prepared statement into insert, and here we go ahead and step that statement. Even if we're not in a loop, we need to step the statement. So always step the statement. There is also a SQLite 3 underscore exec that you might want to look into in the SQLite documentation as well. So if this is not okay, if our result is not okay, then we log out the error, and we have SQLite 3 underscore error message on the database to get to the actual error message. The next thing you have to do, and this is also very important, is finalize by calling SQLite 3 underscore finalize with that prepared statement. This removes that statement or ends all use of that particular statement. So this is very important. All parts is a select everything from catalog query. So we've set up an NS Mutable Dictionary, and this is really pretty simple. We have our SQL, and then we, again, prepare a statement, and it's called select, and we use the SQLite 3 prepare v2 function to prepare that statement in exactly the same way. And then we see if the result is SQLite OK. And you can see a pattern here beginning to emerge. The part number is an NS string, and here we put that SQLite 3 underscore step with the select statement, the prepared query statement, into a while loop. We package these up into an array called values. And we can see that we use SQLite 3 column text for the first two, indexed by 2 and 3, and SQLite 3 column int, indexed by 4, to get back out the name, the description, and the reorder quantity. Finally, we get the part number by using the column text with 1, and we have to package these as objects because we're adding these into a mutable array. Once we have the array, and a part number for the key, then we go ahead and add that to catalog parts. The value is the array, and the key is the part number. The last thing we do here before returning our parts catalog is we finalize the select statement, and then we return catalog parts. Deleting all parts from the catalog is very simple. Our string is delete from catalog, and here's our statement. And we prepare our statement in exactly the same way. We check for SQLite OK in the result, and then finally we call step on the delete query and finalize the delete query. So this removes all existing parts from the parts catalog. Finally, we have delete catalog by part number. The only difference here is we're preparing the SQL string using NSString with format, where part number is equal to escape quote and then the part number, escape quote. And then we call that delete where. We prepare it in an identical fashion. We check for OK, and we step delete where, and we finalize delete where. And here we have deleted a part, a specific part from the catalog using a SQL where clause. So let's go ahead and run this. And remember, I've got my testing happening in main view controller, and it's just logging things out. So let's see what happens. So the first thing I'm going to do is open this up so that I see that we can see that we have added 2 parts and selected them out. We have PN001 first part added, and 15. PN002 second part added, and 20. And then we delete PN001 and log out the result, and that's the PN002. And then finally we delete all parts from the catalog, and we get the empty NS dictionary shown here. Thank you very much.